Okay, Algebra 2 people, today in class we did a lot of graphing of lines. So I want you to just go ahead and take a look at page 71, and it's example 12.1. I think you guys already know this. It has a few things of how to graph a line, especially using the y-intercept notation, which we talked about before. But just make sure you look at page 71. Then, after we looked at that, we talked about solving simultaneous equations and all that means, and we did it in two ways. We did it by substitution, and we also did it by elimination. So we're going to talk about the substitution one first. Solving simultaneous equations. That just means that you have two equations with two variables. So we're going to start off with x equals y plus 5. And we're going to have a second equation that says 3x plus 2y equals 5. If you have an equation with two variables, you cannot solve it. But if you have an equation with just one variable, you can. So when you have these two, what we can do is substitute. This says that x equals this thing right here. X equals y plus 5. So what we can do is in this equation, every time we see an x, we can put this in instead, which will leave this equation with only y's, which means we can solve it. So if we do that, we say 3 times x, or 3 times y plus 5, substituting that in for the x, plus 2y equals 5. Be careful and take a note of all the signs. Watch the signs. When you have negatives and positives, that can get confusing. Then we'll do the distributive property here, which would give us 3y plus 15 plus 2y equals 5. We'll add these like terms. We end up with 5y plus 15 equals 5. Solving the algebra equation, you end up with 5y equals negative 10, y equals negative 2. Now we know what y is. So to figure out what x is, we just have to take this y, the negative 2, and put it in up here in this equation, which would give us negative 2 plus 5, which would mean that x would be 3. So that's how you go ahead and solve it. If you put in negative 2 and 3 into this equation for the x and the y, you'll see that it equals the same. It does come out correctly. So that's how you would solve a system of equations using substitution. We also talked about how to solve them using elimination. And elimination is on page 81. I'm going to turn this over because we need a little bit more space. So we can also have two equations, 3x plus 2y equals 23, and negative 2x plus 3y equals 2. We could do it with substitution, where you would solve one of the equations for either x or y. However, using elimination, we can do it a different way. Elimination means we're either going to try to eliminate all the x's or all the y's. And the way we do that is, we want to, right now, we're going to pretend like this is like one giant either addition or subtraction problem, where we would say 3x minus 2x equals something. We would subtract the y's and we would subtract these. If we do that in the way they are written right now, it doesn't eliminate any of the variables. If you had 3x minus a negative 2x, you would end up with 5x. So that doesn't help you. And 2y minus 3y ends up with a negative y, and that doesn't help. But if we take this whole equation and multiply it by 2, that entire equation, we would end up with 2 times 3x is 6x, 2 times 2y is 4y, and 2 times 23 is 46. Now we're going to do this equation and multiply this whole thing by 3, and you'll see why. Because when you take 3 times negative 2x, you end up with negative 6x. 3, because you have to remember to watch that sign. Now 3 times plus 3y equals 9y, and 3 times 2 is 6. Now you can see we can totally eliminate this. So if we add this whole equation to this one, you see we get 6x plus a negative 6x, which makes 0. The x's are gone. We have 4y plus 9y is 13y, and we have 46 plus 6 is 52. When you do the algebra, you end up at y equals 4. Then you can take this y and put it into the original equation, this 3x plus 2y equals 23, and you get 2y, which would be 8. You would end up with 3x plus 8 equals 23. Subtracting 8 from each side gives you 3x equals 15, which would mean x equals 5. So now you have solved the equation. You have x equals 5 and y equals 4, which can also be written as an ordered pair 5, 4. So the answer could, look in the back of the book, it could either be x equals 5 and y equals 4, or they could simply write this ordered pair. So that's what we did with elimination. Then we also found equations two different ways. We found the equation of a line. The question would be, find the equation of a line passing through points negative 3, 2 and point 3, negative 3. To solve this, you have to make a graph. You have a graph, and you want to make sure that you go up far enough. So these all go up to 3. So using your graphing notebook, you can keep it very nice and neat. We're going to go ahead and plot the points. If you remember, this is the x-axis and this is the y. Negative 3, 2 is negative 3 and 2, 1, 2. So that's right here. 3, 1, 2, 3, and negative 3 is right here. Now we take, and with a straight edge, you would draw a line connecting those two dots. Why does that help us? Well, we want to find the equation of the line. You start off by writing the equation of a line in the slope-intercept form. And you have to remember that we need to find two things to find the equation of the line. We need to find the slope, which is what n stands for, and we need to find the y-intercept. If you look at the y-intercept, it crosses about here, but we don't know exactly what that number is because it's between 0 and negative 1. So we can't just make a guess. We're going to have to find that directly. But we can find out directly what the slope is from this. If you remember, the slope is the rise over the run. So in these 2 points, we can figure out what the rise is. We can see that the rise in this one is actually going to be negative. And the rise here goes down. You can draw a little triangle actually if it makes it easier to see with these 2 points. And we can see that the distance between here and here along the y-axis would be 1, 2, 3, 4, 5. And it would be negative 5 because we went down. Now we want to see how far over along the x-axis that this point traveled. And it went 1, 2, 3, 4, 5, 6. So the slope is negative 5, 6, which we can put back in for m. So we would have y equals negative 5, 6 x plus b. You only need to find the y-intercept and we will be done with this problem. The way we find that is we can take this points from this information. You can see you could put in one of these points for x and y. We can put in, let's use this point. Negative 3 is our x and 2 is our y. So our y is 2, so we'd put a 2 here. Negative 5, 6 times x, which is negative 3. So we put a negative 3 there. And then we add the b, because that's what we're trying to find. When you finish this out algebraically, you end up with 2 equals a positive 5/2 plus b. And you subtract 5/2 from each side, and you get negative 1/2 equals b. So our line was pretty close. I didn't draw it correctly, but that shows that our y-intercept, the point at which this line crosses the y, is at -1/2. So we just have to put that back in the equation for for the b, and we end up with the equation for this line is y equals -5/6x minus 1/2. So that is the equation of the line that passes between these 2 points. So there's one other thing that they'll ask you to find, and it's similar to that, but a little bit easier. Find the equation of the line that passes through -4, 7, which has a slope of -3/5. This one is easier because it tells you the slope. So you start off with y equals mx plus b. We know the slope, so we can put it in right there. And we have y equals -3/5 x plus b. And then we do it just like the other problem. Now we take this, -4 is our x, and 7 is our y. And you would plug -4 in for x, you would plug 7 in for y, finish the equation, and it will end up, when you do all the algebra, which I'm going to let you do on your own, when you finish up the algebra, you end up that b equals 23/5. And it's okay to leave it as an improper fraction. Once you've found that out with the algebra, you would rewrite the equation of the line, then would be y equals 3/5 x plus 23/5. And you can leave it like that. So that's how you find those two equations of the line. The very last thing that we did was we multiplied polynomials and we divided them. And I think you'll find this pretty easy because you've already done the distributive property. So a polynomial just means that it's a expression that has x to different exponents. So it will have like an x squared, maybe an x cubed, in addition to an x. It'll have more than one base with a different exponent. So if we want to multiply this polynomial, 3x squared minus 5x plus 2, and we're going to multiply that by 2x plus 2. We're just going to use the distributive property. And whenever I use the distributive property, I like to have the smaller polynomial in front. And you can switch that. Just like 4 times 2 equals 8, and 2 times 4 equals 8. You can switch them around. So we're going to put the 2x plus 2 in front. And we're going to multiply it by 3x squared minus 5x plus 2. You just take one at a time and do the distributive property, and you watch very carefully the signs. You take 2x times 3x squared and get 6x cubed. Now you do 2x times the minus 5x, and you get negative 10x squared. Then you take the 2x and multiply it by 2, and you get 4x. We're not done yet because we have to do the same thing with the 2. 2 times 3x squared is plus 6x squared. 2 times negative 5x is minus 10x, and 2 times 2 is 4. Now all you have to do is collect the like terms. There's only one x cubed, so we will leave that one by itself. Now we look for all the x squared. There are 2 of them. Watch the sign. It's very important that you watch that sign. Negative 10x squared plus 6x squared is negative 4x squared. Now we have the x's left. We have plus 4x minus 10x, which is minus 6x. The only thing we have left is this number on the end, plus 4. So that would be your answer, and that is how you multiply 2 polynomials together. And then the very last thing is dividing polynomials. We're going to go ahead and take and divide. We're going to divide 2 plus 5x minus 2x squared plus 5x cubed. We're going to divide that by negative 4 plus x. The first thing you have to do is write the polynomial in the correct order. You have to start with the highest number exponent. So underneath our division sign would be 5x cubed. The next one would be a negative 2x squared. Be very careful to watch those signs. Now we're going to add a 5x. And last, we're going to add the 2. In front of here, we're going to take x minus 4. We're going to switch it because we want the x first. So x minus 4. Now you divide just like you used to do long division way back when. All you need to do is look at this x. You don't have to worry about the negative 4 right now. And this 5x cubed. You figure out what you multiply x by to get 5x cubed, and that would be 5x squared. 5x squared times x equals 5x cubed. Now we do have to look at the negative 4. We multiplied those, now we have to multiply 5x squared times negative 4. Watch the sign. When you multiply those two together, you get 5x cubed minus 20x squared. Now you subtract. You have negative 2x squared minus a negative 20x squared, which gives you an 18x squared. Because when you subtract a negative, it's like adding a positive. You bring down the next term, which is plus 5x. Now you want to look at this x, forgetting about the negative 4 for a moment. What do you have to multiply x by to get 18x squared? You multiply it by a positive 18x. Now you multiply, and you get the 18x squared. You multiply positive 18x times negative 4, which gives you negative 72x. When you subtract it, you have a plus 5x minus a negative 72, which gives you a 77x. Be really careful to remember that you're watching all of these signs. That will be where, in first place I would look if you got a mistake, is to check to see if you did the signs correctly. We're almost there. We bring down a 2. We look at what do you have to multiply x by to get 77x. You multiply that by 77. You get 77x minus 77 times 4, which is 308. Plus 2 minus a negative 308 equals 310. And that one just cancels out. So now you have this 310 left. With nothing left over here, you turn this into a fraction. So it ends up with plus 310 over x minus 4. So if you want to take a look and review that, that's on page 84. I would take a look there because it also tells you what to do with ones that are missing, like an x squared or an x or something. So take a look at page 84 for some other examples. Thank you.